All right, so again, we're going to start off here. This is our fourth unit. We'll do a few days today and a couple days before Christmas, and then we'll pick it back up when we come back in January. But what we're going to do is, again, talking about financial stuff. We're going to talk about simple interest here to start off. And what a lot of people don't realize, or a lot of students don't realize, unfortunately, you figure it out as you get older, interest. Now, there's two ways to look at interest. Interest is like a fee for borrowing money, or it's a fee. There's two ways to look at it. Either you're borrowing money, where interest is a bad thing because it's like a tax for borrowing money, or you're the lender, which is a good thing because you are charging somebody a fee to borrow money from them. All right. Now, simple interest, I'll be honest with you, does not really exist today. We don't use it. Now, 50, 60, 70 years ago, they used it because lack of computers. But now we have complex computers, and so simple interest isn't really used. Something we're going to use that is used, we're going to do at 10 o'clock, which is called compound interest. But here is why simple interest is used. Because the formula is simple. And what it does is if you're in a pinch or you don't have a calculator or you can't do all these crazy calculations, it gives you an idea. It's a ballpark figure that you're able to use. All right, so first off, our formula here. We have I, which is the amount of interest. So again, that is the fee that is either being collected or paid, depending if you're the borrower or the lender, for lending money or borrowing money, all right? Principal, P, that is the money that is being borrowed or being lent. Again, there's two sides to this. I'll probably often talk about borrowing money. All right, so that's the amount of more money that you borrow, the principal. R is the interest rate. All right, so that's the rate at which you are borrowing the money. So depending on who you're borrowing from, what they're charging you, that will determine your interest rate. Now, if you're borrowing money, you want a low interest rate because you don't want to be paying as much interest to borrow the money. Now, if you're lending, you would like to have a high interest rate so that you can collect more money for lending it out. Now, the last one here, this is the trick of this whole formula. T is time. But the key here is it's always in years. So what you're going to need to know for this unit, not just this formula, is how many weeks there are in a year, which a lot of students don't know, how many months are in a year, and how many days are in a year. All right, those are important facts that you need to know, not only for math class, but just normal in life in general. All right, so we have our interest is equal to PRT, our principal times our interest rate times our time. Now, again, our interest rate is going to be as a percentage, which, as we looked at last unit in exponential equations, is useless to us. So we're always going to have to convert it to a decimal. All right, so I'm going to go right to example number 3 here, where we start looking at different situations. All right, so I'm going to read it out here. I'm not going to write it out, but I will tell you this, that we are going to use our formula here. I equals P times R times T. All right, so we've got 4 variables here. This is before I even start the question, because I know that's what's going to happen. All right, now, here we go. Ray put $1,000 into a savings account. The interest on the account is 3.5%. He wants to put the money away for 3 years. How much will Ray have at the end of that time period? All right, so what we're looking at is, first off, Ray is putting $1,000 into the bank. So he's lending money to the bank. That is his principal. That's how much he's lending to the bank, if you will. That's how banks make money. All right, now he is doing this. The interest on the account is 3.5%. But as I just mentioned, percent is useless to us as a decimal. All right, so I got to divide it by 100%, and I would get 0.035. All right, so we need I and T here. Now, how much will Ray have at the end of that time period? Oh, he's putting the money away for 3 years. So again, time has to be in years. It is. Beautiful. All right, what we're going to figure out is how much interest rate is going to make on lending the bank $1,000 for 3 years. All right, so I'm just going to substitute my values in. So I got my principal there is 1,000. My interest rate 0.035 and times by 3. All right, so wow, nice little formula here. We just multiply our 3 numbers and I get a nice tidy $105. Now it asks how much will he have in the account? He is making $105 by lending the bank. That's the interest that he's making. So the amount that he's going to have in the account, so A, again, this is a variable we're going to have quite a bit, is equal to your principal, how much you had in there, plus the interest. All right, so there's another formula here. A equals principal plus the interest. How much you had in there plus how much you made. Well, he had $1,000 in there plus another $105 that he made on interest. And so our final amount is $1,105 is how much he would have in his account. All right, now let's try a couple more of these. Let's get rid of this second. Four variables, we'll do 4 examples. We'll solve every one of them here. All right, so then we get to example number 4. That's markers done. There we go. Again, we're going to use our simple interest formula, I equals PRT. And so I always like to write my givens out here. Gets me all straight to what I need. Oops. R equals T, we need T equals. All right. So let's see here. Now, the question is, Beth owes, yikes, $18,000 in student loans. The interest on her loans is 8.25%, 8.25%. She will be paying these loans off in 50 months. Good for her. She must have a good job. How much interest will Beth pay on her student loans? All right. So she is owing. So we have a borrower this time, not a lender. Beth owes $18,000. So that's the principal. That's how much she initially owes, $18,000. All right. Now she's paying off, or this loan is interest rate is 8.25% or 8.25%. Again, I'm going to divide that by 100% to make it a decimal. So I have 0.0825. All right, down to the I and the T again here. Let's see here. She will be paying off these loans in 50 months. So 50 months. Now, time, we need to put that in years. So if I have 50 months, I can find out the number of years by dividing by 12 because there is 12 months in a year. I hope that's not news to anybody here. Speaking of, we're in our 12th month. All right, and if I take 50 divided by 12, that means I've got 4.17 years. All right, so that was the same as the last example, other than the fact we have to make sure the time is in years. That's always been the key of this equation. All right, so just like I did last time, I'm going to sub in my values. So I have 18,000 times my interest rate, which is 0.0825. And then again, times my time, which is 4.17. All right. And the interest, I multiply those 3 numbers. And let's see, what do we get? Whoa, she is going to have to pay. Oh, this is going to be depressing for some of you. $6,192.45. So that's on top of the $18,000. So that's how much interest is accumulated in just 4.177 years. All right. A lot of money. All right, let's try a different variable here. We just solved for I a couple times. Let's go, let's look at example 5. All right, so example 5 is, again, we're going to use our simple interest formula. I equals PRT. And again, we have our variables. Where's this marker been all my life? All right, so another borrowing question. Dave owes Visa card, a lot of money for using his credit card. All right, the interest rate for Visa is 18.5%. That's what will happen to you when you're younger. We'll talk about that stuff as we go along. All right, so again, percent is useless to me. I got to convert it to a decimal, so I'm going to divide by 100%. All right, so I get 0.185. All right, so there's my interest rate. He finally paid off all of the money owed on his Visa after 300 days. So there's our time. But again, that is in days. Now, just flip this to years, because your time always has to be in years. I'm going to divide by the number of days in most years, which is 365. And so our time is going to be 0.82 years. All right. Now, how much did Dave charge to his Visa card if he was charged $183.63 in interest? So there's our interest. That's how much his fee was for borrowing the money. What we want to know is, how much did he actually borrow? All right, so again, I'm going to substitute my values into my equation here. So my I is 183.63. Principal, I don't know. My interest rate is 0.185. And my time in years, again, is 0.82. All right, so I'm going to solve for P. I'm going to put these two numbers together. So I can just multiply them. And let's see, 0.185 times 0.82. We're going to get a decimal here. I'm going to go 0.15, 0.17, or to 17, 0.1517 times P. All right, and then to get P by itself, I'm going to divide by that numerical coefficient there. And let's see here. Those divide each other out, and so I take 183.63. I divide it by my 0.1517, and it looks like Dave charged $1,250.03. All right, so if you borrow that much money at this interest rate for 300 days, that's how much interest he would be charged. All right, let's do one more of those. Again, just trying to find most of the variables here. All right, last one, example number 6. Again, we're dealing with simple interest. All right, so again, I got my 4 variables. All right, so this time we got Julia. Julia deposited $500 into her bank account. After 20 months, there was $516.17 in her account. At what interest rate was her money earning in the bank? All right, so at what interest rate? So we're looking for the rate. All right. Now, she deposited $500 into her bank account. That means the principal, the amount she lent, again, there's always 2 different perspectives here, is $500. All right. Now, what else we got here? After 20 months. So this is the time period that's gone by. But again, time has to be in years. And so I'm going to divide by 12 months to get it into years. And so 20 divided by 12 is 1.67. All right, now here's a little bit of a trick, is that there was, after 20 months, there was $516.17 in her account. Now that's not the amount of interest, right? She put 500 in, and now there's 516 in there. So what really we're finding or getting is that 516 is the amount. 516, what do we got here? 0.17. Now again, your amount is your principal plus the interest. And so what I could do here is I could find the interest by just subtracting 500 from the amount. Right? So I've got 516.17 minus 500. So there's your amount minus your interest. And so that means, or sorry, minus your principal. And so my interest is going to be just $16.17. All right, so a little bit of a twist there. All right, but now I've got all my values, so I'm going to substitute in. So my interest, as I was saying, is 16.17. That's how much was made. Principal, that's how much was put in the account, 500. We're looking for the rate, so there's our R there. And our time was 1.67. All right, now, to simplify things, nothing I can do on the left-hand side here. But on the right-hand side, I got multiplication. Now, you can do multiplication in any order. So I'm going to take that 500, and I'm going to times it by the 1.67. And I get 835. And, of course, times R. All right, but I'm getting R by itself. And so I'm going to divide by my numerical coefficient here. So I'm going to divide both sides by my 835. All right, so those divide each other out. And my rate, I take my 16.17, I divide it by 835, and I'm getting 0.019. Now, that's not percent, that is my interest rate. As we've gone from percent to decimal, we divide by 100. So now when we have a decimal back to percent, we times it by 100%. And so that our interest rate is actually going to be 1.9%. All right, so that's flipping back from decimal to percent. Like I said, most of the time we're going from percent to decimal. This time we're going the other way. But that there again is our simple interest, which again is not used today other than to come up with a ballpark figure. Because again, the formula is very simple and everyone's got a cell phone. You can easily multiply and divide. So. And that is our simple interest. Now, at 10 o'clock, we are going to get into compound interest, which is definitely used today all the time.